Hey everyone, welcome back to my channel EduVibe. In today's lesson, we're continuing the atomic physics with the next topic, which is the atomic spectra, and we are going to start with the Bohr model of the atom. This is the part where we more focus on the spectra. They are the three spectras of the atomic of the atoms. So for that spectra, that is given by the Bohr model. But in the next lesson, we are more focused on the Bohr model of the atom, what they are doing and what the discoveries of the Bohr and what's the model of that. In today's lesson, we move focus on the atomic spectrums. So, Bohr model of the atom, according to the planetary model of the atom, electrons orbit a nucleus in the circular motion. So, its planetary model of the atom is the model of the Rutherford, which we already discussed in the previous lesson, where they discover the nucleus and they said that the electrons are orbit the nucleus in a circular motion. This means there is a centripetal acceleration present, and we recall from the last unit that accelerating charges emit the electromagnetic radiations. So the centripetal force always doing with the acceleration if there is acceleration present, and we done that in the previous lesson that the accelerating charges emitted the electromagnetic radiations. So there's the reduction part can also be involved in that too. So the problem, if the electrons are emitting the electromagnetic radiation, they are the losing energy. So we also did this in the previous unit, that if the electrons are emitting the electromagnetic radiations, which is the kind of the acceleration present, so they are also losing the some energy. So that energy topic can more be uh, done, the more be thoroughly discovered by the Bohr model, which means the electrons in an atom eventually spiral on the nucleus in a few nanoseconds. So that type of thing. In that thing, they losing the energy too. So that topic are like just the introduction of the Bohr model. We discuss this topic in the next lesson with a more like a theory part. So we are today focus on the atomic spectra, which is atomic spectrums. So we have three types of atomic spectra. First one is a continuous, emission, and the absorption. So the continuous, the name says that the continuous one, like which continues like this. Like you see in the when we do the dispersion recombination, like we had the white light go on the prism and we get the rainbow colors. That is called the continuous spectrum. The rainbow colors which are continuous. The colors are continuous with the one. So heated solids, liquids, and the dense gases will emit the continuous spectrum, which contains all the frequencies with no gaps. There are no gaps in it. They are straight, continuous. So all frequencies are with no gaps, and they made with the solid, liquids, and dense gases when they emit. So, for example, the sun emits the continuous pattern of light, as I told you, we did it in the dispersion that topic. Through we only tended to see the yellow light and sometimes orange, red around the dust and drawn to the really restricting. So this is crackling type of the thing we already. This is electromagnetic radiations. The emitted electromagnetic radiation in a continuous spectrum is due to collisions between the atoms. So their main part of this is the atomic spectrum is due to the collisions. When the atoms are collide with each other, they will make a continuous spectrum. The next spectra is the emission spectrum. So in this, when a gas or vacuum tube is supplied with a high voltage, now the electrical part is involved in that. So when a gas in a vacuum tube is supplied with a high voltage or the heat, one will notice that the gas gives off light. That gas with the high voltage will give us the light, a globe. So when, however, this light is arming through the diffraction gradient, something interesting happens. The continuous spectrum is not visible. So in that case, when we like gas vacuum tube is supplied with the high voltage and the light gives off the light, so we examine that there's a through a diffraction gradient. They do some diffraction gradient part, which we already discussed in electromagnetic radiations too, and there is no continuous spectrum now this time. Either one can only see the distinct lines of colors. As you know that the diffraction gradient is the thing where we see only the not all the colors, we see some distinct lines of the colors. We see the lines of the colors like in this you can see. You can see over there, these are the some lines and they are all black, and then we have some lines like different color lines you get from here, and all and all. So this all are called the discrete lines of color with the different area, and this type of thing we call the emission spectrum. So what else I will notice is that each atom will emit bright bands of color at the specific frequencies or wavelengths. This is known as the emission line spectrum. This is also called the emission line spectrum. Each element has a unique emission line spectrum. A think of is a fingerprint of the element. So every element has a different type of emission line spectrum. This is like a fingerprint of the element. So the middle electromagnetic radiation emission spectrum is from excited electrons in an atom transition down to a lower energy state. That transition that they mentioned down to a lower energy state and their excited electrons, that all terms we discuss in the next lesson in the Bohr model of the atom, which is the very important lesson. This is only the spectral part we do. We do the more in this later on lesson. So the last spectra we have a absorption spectrum. So absorption spectra and the emission spectra are interrelated. So how they interrelated? Instead of looking at the light from the hot gas through a diffraction gradient, we can also shine white light through a cool gas and examine this light through a diffraction gradient. So that all emission thing we done with the gas we're tuned to with the heat. But when we like shine a white light on a cool gas, so we get a absorption spectrum in that case. But there is something in this. So the gas will absorb the light from the continuous white spectrum at the same frequencies again, and which will emit the emission line spectrum. They also emit the emission line spectrum like thing. But difference is that they emit the things which are not present in the emission spectrum. Like the black part, this mercury is the emission spectrum, and this is the absorption spectrum. The black part is not over there. So this black part is represented, which colors the black part has, it represented by the absorption spectrum like this. These all part has a red color. And the yellow color we have at line, which is from the emission spectrum. In the absorption spectrum, we see that as a black thing in the same, but the difference of gases. But these are like a other view of the emission spectrum with the absorption spectrum, which things are not visible in the emission spectra, we visible those things in the absorption spectrum. Therefore, when they're looking at the continuous spectrum, dark bands will appear at the frequency wavelengths where the light was absorbed. These dark lines known as the absorption line spectrum. So these dark lines are now the absorption spectrum, which are these lights are absorbed by the emission spectrum. So that's how they both are interconnected with each other. The missing bands of light in absorption spectrum correspond to the same wavelengths of the light absorbed in emission spectrum as you see from the below. So as I told you, that thing can be do. That emission spectrum will do with the heat, and this will go with the cool gas. They're doing the same thing and they are interrelated with each other. So we have some example of this. What type of example you get? That type of thing. But sometimes you get this type of example too, that you have to find the where the missing elements in this. That will discuss in practice questions. But for now, we discuss this question that we have to say that identify what type of emission spectrum as with the following descriptions. First, we have a low pressure or neon gas is excited by a current and gives off the light. So they evolve in the current. When they evolve in the current and gives off the light, so which means we have a emission spectrum that we discussed already. Next, the light from the sun after it goes to a cold atmosphere. So they mentioned they will have a cold atmosphere, but there's a sun. The sun involves as a white light, and they go with the cold atmosphere. So which means we are discussing about the absorption spectrum. The light emitted from a hot metal. That hot metal, when they emit it from the hot metal, we are talking about the continuous spectrum in that case. The entire spectrum of the color is present, but there are a few dark lines. So we have a few dark lines, but we have an entire spectrum, which means that we have a absorption spectrum in that case. All frequencies of electromagnetic radiation are present. So all frequencies we have, there's no any gaps. They are all fitted with no gaps, which is the continuous thing. So we have a continuous spectrum. There are only few bright bands of color absorbed. So we have all the black thing, and we have some few bright bands, which is the emission spectrum. So that's how you can identify this thing, and that is like a kind of definitions for all of three spectra you can do with that, and you get that of questions, other question we design the practice questions too. So only that question you have some know the theory in this, you get some MCQs, get some like MCQ questions you get. So that's all for this lesson, and this is the more lesson which we cover the spectra part of the Bohr model of the atom. But in next lesson, we more focus on the Bohr model, which they use the all the things which they mention the energy levels, shells, and all. So we discuss in the next lesson. For now, this is all for this lesson. Let me say if I do vibe learn smarter, not harder. Please like, share, and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Let's get with EduVibe.